Perfect. So first, thanks to Kati and the other organizers for giving me the opportunity to talk here. Today I'm going to talk about computational fact-checking. It's a kind of interesting project that I took on as soon as I arrived here at CNETS, and it went through several phases. So you probably have seen at least once any of these, 9/11, Beatles. So these are all examples of conspiracy theories and misinformation. These days on the internet, you see a lot of these things here, like memes purporting weird ideas. But it's interesting to see that this is not really a phenomenon of the internet. Yesterday was like idle browsing to gather all this stuff, and looks like that there were, immediately after the Pearl Harbor attack, a lot of people thought that was like kind of a setup. It was kind of allowed to the Japanese to attack, and then of course the king, all this kind of stuff. And the other phase of the misinformation. So this is, you can imagine, this is kind of all grassroots misinformation that comes from like normal people that don't really understand how complex the world is, and they come up with their theories. The other phase is like politicians. We know politicians tend to like be not very accurate, and this is really so these statements are collected by this website PolitiFact. And they do like what are called a manual fact checking, and they actually give an assessment of the accuracy of the statement. As you can see, so this is, I think, this is a Congress member from the Republican Party, Michelle Obama, and then these are also two other Congress members, I think, from the Republican Party, though. So it's kind of bipartisan. You can find politicians from both sides of the spectrum telling inaccurate statements. So of course one could wonder, like, okay, well, but you know, like, we are in a democratic society, everyone is entitled to their opinion, what's the problem, right? Problem is that when you start seeing that this kind of ideas, inaccurate ideas or weird facts become persistent and have the chance to skew the public debate. So for example, the Pew Center compiles statistics about how the percentage of people that still believe that as of 2010 that whether Obama was Muslim or Christian and so on, and they found that like 18% of the American public as of 2010. I don't know what's the current percentage, but at that time was like quite a huge, large minority that's quite worrisome. So, so the current state then is that the internet is awash with lies and stupid things. Politicians tend to lie and so on, and we have like this problem that it all may lead to a dumbing down of humanity. But there are serious consequences, I think. And traditionally, the approach to fight all the misinformation that's always been with us has been to do what journalists call fact-checking. And it's a classic example. You don't just check the syntax and so on, but you actually check the facts. And this was something that, it's a manual activity. It's not really new. I mean, even like in early 20th century, really with the modern newspapers, the figure of a fact checker arose. But these days, it's really like only large organizations like the New Yorker, Der Spiegel, and so on can afford to have like a dedicated department that can fact check all the stuff that they produce. And so the natural question is, we have this painstaking manual activity, can we help by automating it to make it more efficient, more prompt especially? And of course, we're not the only one who have thought about this. There's a lot of other organizations, startups. The Washington Post has this really cool idea of a prototype of, they take a video, they extract audio from it, they take sentences, then they match them against their database, and as you watch the video, like what is said, you see the transcript and it highlights it. But it's a prototype, it works like on 3 videos. There's Snopes that collects like urban legends of the kind of like the Illuminati and so on. And there are also like more serious, like this is a European project that recently started about finding the like determinants of misinformation and so on. And a bunch of startups here, see TrueClick and so on and so forth. They're more or less specialized. I think TrueClick is specializing on like financial news, for example. So there's a lot of activity here. The other side of the coin is that on the internet is not only a land of inaccurate claims, but over the years we've seen that it's actually possible to build in a reliable way, I wouldn't say like perfect way, but at least decently reliable way, new knowledge and gather especially existing knowledge. And this is a classic example when Wikipedia was so this kind of like, there's an interesting story behind this article, but I won't go into it. But this is like the classically quoted article. It's referenced a lot when people have to use Wikipedia data, saying, well, it's reliable because Nature did a study, and they found out that the average number of errors compared to Encyclopedia Britannica is more or less the same. There was like a side of polemics, and of course the people in Encyclopedia Britannica were not very happy, but I won't go into all the details. But the point is that nowadays there's a lot of knowledge bases, not just Wikipedia, which we all know, but more specialized one, like semantic bases, like Freebase, which is owned by Google, or Yago, which is an academic project. And I would claim they are reliable enough. An example, early on, people looked at how long it takes to repair common vandalism, and in a large majority of the cases, they found that it's repaired in a matter of minutes on Wikipedia, for example. And there are large-scale systems, which is novel. Before, people had to gather these like knowledge bases, and was really time-consuming. And especially in our case, because we are in a network science colloquium, they can be seen as instances of large-scale knowledge networks. And this is very interesting. Here we will use, I'll try to move this, yeah. We focus on DBPedia, which is pretty much extracting information from Wikipedia, but not from all of it, only from the so-called infoboxes. So you probably know, you've seen many times a Wikipedia page when they have like this kind of like simple recap of all the major points of information about a given topic. In this case, Barack Obama, well, that is the 45th president, is incumbent, who preceded him, and so on and so forth. And when you look at the actual source code of this, you suddenly realize that's quite amenable to machine like reading, because it's really like a list of attributes and values. So this is the Barack Obama, and then it says the vice president is Joe Biden, and so on. And what the DBPedia project does is extract these kind of info boxes and puts them in a more manageable form. So one can start like accruing information about various topics. We add also more and more information, and more information, and so on. And what we end up is a knowledge network. And a knowledge network, meaning that we have nodes are entities, for example, Obama and socialism, and the statements that we saw before form the edges that connect with other entities. And of course, most of the time you have a lot of facts, and sometimes you have things that there are not in the knowledge network, and you might wonder, does all this trove of knowledge provide support for this novel statement? And just to give a some quick statistics of this about the DBPedia network, we were using kind of old version. They updated recently, but it contains 3.14 million entities, facts about 3.15 million entities, 23 million facts. This is the degree distribution of nodes, and as you can see, there's a very clear heavy tail. I didn't check if it's power law. I can tell you that this kind of hump here is due to the out degree distribution, pretty much because info boxes are kind of bounded. They cannot have like 10,000 entries. But you find a lot of entities that receive a lot of links, like United States, Barack Obama, and so on. And so this like the tail is more like the in degree part of the distribution. And of course, you have a lot of predicates, and they cover a lot of things like countries, birthplaces, musical genre. This one, which is the largest, the most frequent one, is what in the semantic web jargon is the ontological relation, or subsumption relation, which is like Obama is a politician. And it's this one basically, and this is the rank frequency plot of the stuff here. Okay, given this framework of thinking about this large scale base of knowledge, we think it in terms of a network, and of course we can start assuming that everything that is on the network is essentially true. We trust it. But of course, then the network can imply new things out of indirect connections. And the classic example that I always use is Obama and socialism. And many people try to, like, we can imagine, like, intuitively that the amount of work that a human agent, given a network like that in their head, or the knowledge they have, if they had access to all the knowledge, they would start looking for, like, a way to resolve a statement that is not present. And we can imagine that the amount of work needed to resolve this statement could be likened to as the inverse of the confidence with which we would believe to this statement. If it really takes a lot of time to find a decent series of connections between these two entities, probably wouldn't trust it. And so on a network, this would translate into the concept of finding a path that links to nodes that might not be immediately already connected in the network. And Luis, I believe, will talk more about this concept of graph closure, finding indirect paths. So I won't, but I'll just tell you the name. But really, it's like finding paths. And so, of course, as you can imagine, because this is heavily interconnected, it's very easy to find a lot of paths connecting any two given entities. So this is actually extracted from the DBPedia. It's one of the, I think this was one of the most important, probable paths according to one of these closures. I'll talk more about this. But the idea is like, well, Obama, he probably appointed this politician of Indianapolis. Indianapolis is a twin city of Monza, Italy, which is ruled by the Democratic Party, whose color of, I think the symbol is red, which is the color of socialism. So now, of course, if somebody would tell you, well, you know why Obama is a socialist, I have the clue. You wouldn't believe it. But maybe there's another, there might be also other paths that are more, let's say, more to the point. But what really makes this path, this series of concepts, unbelievable? Well, one of the things we thought intuitively is that it goes through a lot of entities that are very general. And I'll give you another example. Imagine that you want to say, well, you know, Barack Obama is a man, and also Vladimir Lenin is a man, therefore, and Lenin is a socialist, so therefore. And of course, like the classic counterexample is like, well, of course, then any man would be a socialist, right? Any here means that you're going up to an entity that's very generic, and then down to another entity. So we want really to penalize this kind of like going up this hierarchy, this ontology, and going down. So the idea here is that when you have a path like this, we'll probably go through like some entities that are very, very generic, and which means that they will have a lot of connections. So there will be hubs in the network. And you can imagine that you have all these paths, and you can formalize this, meaning that like the notions of distance for you is that if you go through nodes that are very well connected, you want to give them a lower weight, a higher penalty. We're using the logarithm for information theoretic reasons, like more of an analogy. But basically means that you have a path, you can assign to it and attach to it a number between 0 and 1, and then you want to basically take the path that is most meaningful, the one that gives you most information. And so you maximize this thing. Another option, because this is kind of arbitrary, you could also say, well, really, like the this amount of this chain of causal of reasoning, let's say, is really as strong as the weakest link. That's another way to put it. And this you could translate it more into like a bottleneck. So you want to find a path that goes through the widest bottleneck, the one that gives you the lowest penalization, if you want to see it in the other way around. And also, again, you cannot experiment with this. And so, of course, there are different ways to formalize this intuition. And we did a study to see which one was the one that best performed. I won't go into these details. But we found that basically the previous one, the normal notion of distancing graph in the sense of Dijkstra, if you are a computer scientist, know what I talk about. But really, like, the idea is that every part of the path contributes to the overall weight of the whole path. And you want, of course, to maximize this thing. Of course, okay, you have this nice toy. Let's put it to work and see if it actually gives us meaningful things. As you can imagine, like, there's a high degree of interconnection between similar concepts. So maybe this pathfinding algorithm is able to find equally good connections between things that shouldn't really be connected with the same weight. So if I ask it, okay, was Jacqueline Kennedy married to Barack Obama or to JFK, and the same for Michelle Obama, I would like to have this, but not this, right? And so it's really a sanity check in a sense, so like asking, is Paris really the capital of France, or will the method tell me that is equally well connected with, for example, Russia? Okay. And we tried a bunch of data sets trying to cover different topics. Oscar directors awarded for the best movie versus the movie for which they were awarded, states and their capital in the United States, in the world, and presidents and their spouses. And of course, here you can imagine that if you go back in the info box of Barack Obama, you will see that, well, there's already the fact that Obama is married to Michelle Obama. So if we did this exercise on the whole network as it is, it would be eminently trivial. So the idea is that you first remove this direct edge, if there is any, and you see if the remaining knowledge is able to tell you with confidence that that thing was true. And the results are, you can visualize them in terms of confusion matrices. So for example, here you have the first lady, the presidential spouses, and the presidents. And so the correct answer is always on the diagonal. And the color maps to, the intensity of the color maps to this confidence score, this what we call a truth value. And as you can see, when we ask Van de Metel which one is the correct answer, meaning the one that has the highest truth value, in these three cases, we're really quite good, actually. On this one, on the Oscars, there's more confusion. And an interesting factoid that I will leave to you, there's kind of like a separation between these old movies. These are arranged by the year of the award, and the new movies. And the border one is the Graduate with Dustin Hoffman. So in case you like movies, you know now that that's really the one that changed the new Hollywood. So okay, but this is a very encouraging result. We don't have enough. There is some confusion, of course. Like countries in the same continent, for example, tend to have higher levels as opposed to other continents. But still, we recover the correct answer. Okay, super quick. Second, more challenging task. That was all stuff that was already inside the encyclopedia. That was very well connected because these are presidents, countries. Of course, Wikipedia covers this stuff a lot. What can our method do for more peripheral topics, like people that are not able to have enough to have a Wikipedia page, but maybe they don't have many facts recorded into the database? And for this, we were lucky to find that Google had just released a dataset that exactly did that. What they did was to extract statements from Wikipedia, from the text, actually, of the Wikipedia pages, not from just the info boxes. And they focused only on a few relations. Those where we used were the institution, of affiliation or whether somebody got a degree from a given university. And in these cases, for example, this is a screen player. He attended Indiana University, at least from the text, was asked to people on the Mechanical Turk to assess whether this was the case or not. And so in this example, 3 out of 5 said it was the case, and we can take it as a kind of majority vote, as a ground truth to say that, yes, this is the case. And now then we can go back to our method and ask, okay, given these statements that are not in our database, and they are on top of that about very peripheral topics, can we still do something decent? And here I'm displaying the so-called receiver operating characteristic curves. This is kind of a classification task. The red line here means that these are the performance on a purely random classifier, somebody that just picks blindly at random. And we do a little bit better than random, so this is kind of an encouraging result. To close out, of course, this is just the beginning. We don't claim that we can really do fact-checking in the way professional fact-checkers do. There's a lot of reification, like many times politicians say that somebody said something else, and so on and so forth. But really, like the grand vision would be to see, like, you have somebody saying something on Twitter, you would extract what he's talking about, and then you would like to attach a value of confidence of this statement to what people say. This could be kind of a good tool that could help people to sift through all this sea of misinformation that we see on social media. This is a joint collaboration with a lot of people that I would like to thank, Sandro Flammini, Luis, Johan, and Prashant, who I think is not here. And thank you very much.
We do have 4 minutes for questions and answers.
Yeah.
It's interesting. I think you try to define distance function, for example, function on graph, right?
Mm-hmm.
So do we have a chance to compare your algorithm with some other, like a textual-based distance function, for example, like Google distance? So I'm very interested to see like Google distance. This is very easy, just co-occur of 2 things.
Mm-hmm.
Without.
You mean in the same page?
In the same page, yeah. Probability of 2.
Okay.
Like, yeah, if you think Washington is the capital of U.S., so
Mm-hmm.
basically saying if they co-occur a lot in the Google result, that means they correlate.
Mm-hmm.
Do you think your algorithm may have a chance to outperform? Then
that's a good question. We didn't try that, but it would be really interesting to do it. I think it really depends on whether co-occurrence is related to this. Like you co-occur a lot with you have a lot of chances to occur a lot with very generic things, right? Like a city will for sure co-occur with its country and so on and so forth. I cannot really tell you what I would find. I hope, yes, that could be interesting. But yeah, we can chat later because it would be interesting to see this kind of data.
Any other comments, questions, suggestions?
We try to prevent some kind of repercussion, like Obama is America.
Oh, do damage to the network, you mean? You mean remove nodes? No, we tried only to do this kind of link prediction when we do both validation tasks, because of course it would be trivial if it's already in the info box. Then all this machinery is basically useless. And but we didn't really try to eliminate a whole node. That would be interesting, though. I think if you eliminate, if you remove hubs, usually like the interconnectivity is lost quite fast. So. Mm-hmm. Yeah.
Thanks so much again.
Thank you.